How's everyone doing? You're back with Jono for another quick math lesson. Today we're going to look at the sine rule, and specifically we're moving from right angle triangles, which we're incredibly comfortable with, into the world of non-right angle triangles, which opens up trigonometry in a massive way. We've seen during the unit circle that we're not actually bound to just a 90-degree right angle anymore. We can find out the sine, cos and tan of angles that are obtuse, reflex, or even the whole way round. So that means moving into non-right angle triangles, we can find out a lot of information using these ratios in specific ways. So to see the foundation of the sine rule, all we have to look for is a couple of patterns when we look at a triangle. They're actually pretty easy to see, and we're going to go through a couple of examples here. So the pattern that we're looking for is the relationship between one angle and its opposite side length. So if I make that angle, instead of 131, if I make that smaller, what that's going to result in is a smaller opposite side. That has to squeeze in as that angle becomes less. And then as I open that angle up, if I extend it out, obviously the other side of the triangle has to open up and become longer. So there is a direct relationship between one angle and its opposite side. And this happens as well, even if we've got two angles going at the same time. So now if I've got angle A down here and its opposite side length, as I open up angle A, as I make it larger, the opposite side becomes bigger. And then when I close it back down, the side length becomes smaller again. So the really fundamental thing comes from this pattern. As we open or close the angle, the opposite side moves in the exact same way. So the important part of that is that the largest side length goes with the largest angle, and they're always across from each other or opposite. And that's incredibly important. The opposite sides are connected, and the smallest side goes with the smallest angle. Again, always opposite. And if you've got that in your brain, you're going to be okay. So the reason that we highlighted that was because there is a relationship between the size of the angle and the size of the side length. All the sine rule's trying to do is actually tell you exactly what this relationship is in numbers for every single non-right angle triangle that you're going to see. So proving the sine rule is actually a really common question that you might see in an exam, and the proof is actually incredibly easy. Even though we're dealing with non-right angle triangles, just one perpendicular line from the base up to the top will create two right angle triangles within your non-right angle triangle. And that's the start of what we do. All we've got to do then is use our trig ratios from right angle triangles, our SOHCAHTOA, to find the height of that line coming from the perpendicular. Once we've got those two things, the rest of the proof's actually incredibly easy because we just have two simultaneous equations going off at the same time. So we're going to use this triangle to prove where this law comes from. So if I've got this here, the first step that I need to do is put a perpendicular line from the base all the way up to the highest point. And that's going to cut this into two right angle triangles. And that's the basis of what we're going to do. So here we've got two right angle triangles. As you can see, the angle, big A, goes with the little side A on the opposite side, and that is actually going to come into play really soon. So if I call this altitude here H, or for the height, so we can find out what H is just using SOHCAHTOA, and we can use it using each of the two triangles. So to find H on this side over here, the H there is sine A, or sine of the big angle, is equal to opposite over hypotenuse, which is the little b, so that is h over b. I want to find h by itself, so h is equal to b multiplied by sine a. And that's all the working out we've got to do. But I could have used this triangle on this side to find out the exact same thing. I've got the angle b there, the opposite side, and a hypotenuse, which means I can use the sine rule again. On this side, sine b, the angle, is equal to the h again over the hypotenuse, which is a. To get h by itself, I multiply both sides by a, so I've got a sine b. So now I've got h equaling two things, which means those two things have to be equal to each other as well, okay? Because h is the same for both triangles, they have to equal each other. So that means that b sine a is equal to A sine B. So this is actually the final step of the law, but we want to have our A's on the same side and the B's on the same side, just to make it look a little bit prettier. So if I divide off the side length, so the little a and the little b, over to the other side of each equation, we're going to end up with this. Sine A divided by A is equal to sine B divided by little b. And the sine rule actually goes a little bit further. These two things are correct, but you could have used the other angle as well. So that means that this is also equal to sine C over little c. So the sine of the angle divided by the opposite side length is equal to each other combination of these two pairs. So it's really important that we've got this. The other cool thing about the sine rule is that it actually works in reverse. So if you're looking to find an unknown side length instead of an angle, the same thing works in the other way. So one thing you've got to make sure with this is that you have the same type of numerator and same denominator. If you're looking for an unknown angle and all the angles are on top, that's totally fine, but you can't have angle on top and then side length on top, right? It all has to be the exact same kind of thing. So in order to use this, we've got to look for two things. Firstly, we need to have two sides and two angles, definitely. And we want them in opposite pairs, okay? One of these is going to be unknown, that's what we're looking for, but we need to have two sides and two angles in order to do this. The other thing that we're going to do when we start using this formula is you have to put the unknown in the top left-hand corner. That's just going to reduce the amount of maths that you have to do. And if you can do it correctly, it means that we've really only got a one-step equation every single time we're doing these. So for this one, we've got to find x, okay? X and the 96, these two are a pair and they have to go together on the same side of an equation. The other two, 24 and 18, they're the other pair, and we're going to make them on the right hand side in order to find out what x is equal to. So because I'm trying to find a side length, that's what's going to go on top of my fraction on the left hand side. So I've got x over sine 96 is equal to, making sure I've got side lengths on top, 18 over sine 24. And so because we want x by itself, we've got x divided by sine 96. All you have to do is multiply both sides by sine 96. So my final answer is x is equal to sine 96 multiplied by 18 over sine 24. Type that into your calculator, incredibly easy, and you'll get the answer of 44.01. And that's all we've got to do. There is a nice way to check that you've got this correct. Okay, so because 24 is much smaller than the angle of 96 inside, we know that that x has to be a bigger number than the side length that we were given. So because 44 is bigger than 18, we know we're on the right track to getting this one right. So in this one, we're going to find an unknown angle. So again, we want to change the formula to suit our needs. So we're going to have the unknown angle at the top left of this equation. So this is sine theta over 30, its pair on the opposite side, is equal to sine of the angle we're given, which is 103, divided by its opposite side length, which is 48. Now I've got to multiply 30 to both sides to get rid of that division. So sine of theta is equal to 30 multiplied this whole side, sine 103 divided by 48. What I like to do now, just to make sure my calculator doesn't do anything funny with rounding, all you have to do to get theta by itself is the inverse of sine. So I type into my calculator, theta is equal to sine -1 answer. So if you throw all of this stuff into your calculator and then just hit inverse sine answer, that's the most accurate way, just to make sure you don't get any rounding errors within your working that could lose you a mark. So if I throw that into my calculator, I get the answer of 37.5 degrees. So because that obtuse angle is 103, I need to have two acute angles. So because I've been given 37, I know I'm on the right track because it fits in with what's possible within this triangle. Finally, you could get some that look like this. We need to have opposite side pairs. That's really important, right? Sine A and A go together. These two opposites need to be within the question. But in this one, it looks like we don't have any opposite pairs. This 2 doesn't have an opposite over here, and the x doesn't have an opposite side length on the other side. Some students freak out and think, oh, I can't do this, I need to use another law, but it's actually really easy. If I can find out what this angle here is, I know that a triangle's got 180 degrees, so I can just minus off the two other angles in order to find out what x is, or what's left over. So just be on the lookout for this, even though you might not have perfect opposites. If you've got two sides and two angles, you're going to be all right. So because I've got this made up theta on that side, that's going to be my top left. So sine theta over its opposite, which is 2, is equal to sine 136 divided by 4. We've seen how to do this one already. We've got to multiply the 2 over to the other side. So sine theta is equal to 2 multiplied by sine 136 over 4. Again, I just type that into my calculator, it gives me some number, and then theta is equal to sine -1 answer. Type that in, and that is your final answer there, which is 20.3 degrees. So now that's what the theta was, that's not what I'm interested in. My unknown was x, but because I know two angles, I can find out the third one pretty easily. So therefore, 180 minus the 136 I was given, minus that answer of 20.3. You throw those into your calculator and you're left with 23.7 degrees is what x is equal to. Just make sure you do say x is equal to this so your teacher knows exactly where your marks are going to come from. I do hope you found this helpful, and I'll see you later.